In this video, we will talk about regions between curves. First part, integrating with respect to x. We consider two graphs, f of x and g of x, as f of x is greater than or equal to g from point A to point B. We are going to find the area between these two graphs by using the slice and sums technique. The idea of this is making into subintervals and then consider the area of the small rectangles and add them all up, which is called the slice and sum technique. The formula of this one is about the integrating of the height, which is the upper function minus the lower function values times the width, which is the dx. If you look at one piece of the rectangle, the width is delta x and the height is the difference of two functions. The height times the width gives you the area of one small rectangle, but we have many of them that covers the entire area bounded by these two graphs. And the width is a change in x that tells us this is the integrating with respect to x or using the x as the independent variable. Example 1. Determine the area of the shaded region in the following figures. Example 1. Determine the area of the shaded region in the following figure. We see the graph of y equals to x and the curve y equals x squared minus 3, and the region bounded by these two graphs. You can see that the line y equals to x is above the curve y equals x squared minus 3 for the entire region. First of all, we are going to find the intersection point, which is the lower bound and the upper bound of the graph. To find the intersection point, we let y1 equals y2. y1 is 2x, y2 is x squared minus 3, and solve quadratic equation. Factor completely, we have x minus 3 times x plus 1. We get x equals 3 or x equals negative 1 as the intersection point. Negative 1 over here is 3. This will be your lower limit and upper limit of the integration. Next, to find the area. How do you know it's with respect to x or with respect to y? As you form the small rectangle and pretend that you move this rectangle along the shaded region, it stays in the same way as a vertical bar. That means the change in x or the delta x remain as the width of the bar. Delta x is the same as dx. That tells you this integration is with respect to x. To find the area A, set up the integration. From lower limit, negative 1, upper limit, 3. The upper graph, in this case, the upper graph is 2x. The lower graph is x squared minus 3 with respect to x. The integrand form the height of this bar. And the dx is the change in x or the width of each bar. Simplify a little bit more for the integrand. We have 2x minus x squared plus 3 with respect to x. Next, use the antiderivative formula for each term. First term we have x squared. Next one we have minus x to the third over 3 plus the last term 3x. Evaluate from negative 1 to positive 3. Substitute the value into the terms. We have 3 squared minus 3 to the third over 3 plus 3 times 3, subtracted by the quantity from the lower limit. Sorry, which is negative 1 quantity squared minus negative 1 to the power 3 over 3 plus 3 times negative 1. Simplify completely. We will get 32 over 3 or 10 and 2/3 as the final result.